Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 3-4 graphing functions, which also includes some piecewise functions. Alright, so evaluating piecewise functions. Alright, so a piecewise function has different rules for different parts of its domain. The greatest integer function is a piecewise function whose rule is denoted by the symbol with the x, right? Which represents the greatest integer less than or equal to x. To evaluate a piecewise function for a given value of x, substitute the value of x into the rule for the part of the domain that includes the x. Alright, so if we are finding f of negative 3, f of negative 0.2, f of 0, and f of 2 for f of x with this piecewise function, what do we need to do? So, negative 3 is less than 0, so we're going to use the rule f of x, or y, equals negative x, right? So with negative 3, if we're trying to solve for f of negative 3 fits in here. So we use this. So we go negative 3, right? Which is bam, bam, positive 3. The answer is positive 3. I get a different pen. This one's dying. This one's not much better. Hold on 1 second, guys. Find a pen that works. Alright, here we go. Got one. Bam, bam. 3. Alright, so if we are using negative 0.2, negative 0.2 also falls on the top one, so we're going to have negative 0.2, bam, bam, 0.2. So we're using this rule. Alright, what about f of 0? 0 is not included here, but it is included here, so we're going to use this rule of x plus 1. 0 plus 1 is 1. For our last one, 2, 2 is greater than or equal to 0, so we're using this rule. The rule f of x equals x plus 1. So we're going to have 2 plus 1, which is 3. Find f of negative 3, f of negative 2.9, f of 0.7, f of 1.06. And y equals, what does this mean again? It means the greatest integer less than or equal to x. The greatest integer less than or equal to x. Okay. So we have our rules. This is our piecewise function. Negative 3, let's do negative 3 first. Where does negative 3 fall? Negative 3 would fall in here. It does not fall between these. So negative 3 is in this interval. And in that interval, the answer is negative 3. Negative 2.9 falls in here, so the answer is negative 3. 0.7 would fall, it's positive 0.7, so that's between 0 and 1. So our answer is going to be, is this just not written in here? Let me look. This should have a 0 written here, guys. Negative 1, 0, 1, 2, and so on. So the answer is going to be 0, because it falls in the interval of 0 is less than x, which is less than 1. 1.06 falls in the interval, so this is actually going from negative 1 to 0, from 0 to 1, from 1 to 2, from 2 to 3. Okay, so 1.06 falls in here, right? So that's going to be 1. See how it's going from -3 to -3 to -2, -2 to -1, -1 to 0, 0 to 1, 1 to 2, 2 to 3. Just following that pattern. Why should the parts of the domain of a piecewise function have no common x values? Why should they have no common x values? So, you want only one rule to apply to a given x value so that you only get one y value. Since a function must have only or exactly one output. Wow, how did I spell that? One output for every input. For positive numbers, how is applying the greatest integer function different from the method of rounding to the nearest whole number? For positive numbers, how is applying the greatest integer function different from the method of rounding to the nearest whole number? All right, well, let's look here. Are we rounding to the nearest whole number? So between like 1 and 2. 1.1 rounded to the nearest whole number would be 1. But 1.9 would round to 2. But here we're going to 1. Does that make sense? So we're not necessarily rounding to the closest number because 0.5 and up, we're not rounding up. Do you get what I'm saying? So, when you round a positive number to the nearest whole number, you round down if the tenths digit is 4 or less, and you round up if the digit is 5 or more. For the greatest integer function, you always round down. Graphing piecewise functions. Graph each function. Y equals negative x, then it's going to be if x is less than 0. And it's going to be y equals x plus 1 if x is greater than or equal to 0. So complete the table, use the values to help you complete the graph, extend the pattern to cover the entire domain on the grid. All right, so if I plug in -3 is here, so it's positive 3. If I plug in -2, it's going to also fall here, I get positive 2. If I plug in -1, I get 1. If I plug in -0.9, I get 0.9. If I plug in -0.1, I'm going to get 0.1. Or 0.1, right? If I plug in 0 or equal to 0, I'm going to get 0 plus 1 is 1. If I plug in 0.1, I'm going to get 0.1 plus 1 or 1.1. So 1.9. 1 plus 1 is 2. 2 plus 1 is 3. The transition from one rule, negative x, to the other rule, x plus 1, occurs at x equals 0. Show an open dot at 0, 0 because the point is not part of the graph. Show a closed dot at 0, 1 because the point is part of the graph. Okay? So we do have the point 0, 1. That's right here. But 0, 0 we don't have. So it goes from here all the way up. What else do we have? So we have the 0, 1. Then we have 1.1, or sorry, 0.1, 1.1. We have 0.9, 1.9. We have 1, 2, 2, 1, 2, 3. So this one's going like this. So open dot here, it goes this way, and then it switches over to the other rule and continues like that. And it is a function. It passes the vertical line test because this one's solid, but this one's open. So there's no overlapping point. When you do the vertical line test, yes, this is a function. It passes that vertical line test, right? Let's look at the next one. Y equals the symbol, which means, what does it mean again? The greatest integer function, right? It represents the greatest integer less than or equal to x. All right. So we just round down, right? So this one's going to be negative 4, negative 4, negative 3, negative 3, negative 4, negative 2.1 is going to round to negative 3, negative 2, negative 2, negative 1, 0. 1's going to stay 1. 1.5 rounds down to 1. 2 goes to 2. 3 goes to 3. 4 goes to 4. Why is negative 3.1 negative 4 and not negative 3? You're rounding down, which is a lower number, not a higher number. Negative 3 is less debt. That's better. We're going down, so you have to go to negative 4. Does that make sense? Negative 2 is less debt, so you have to go to 3. Negative 3, because you're rounding down. Are you guys okay on this? So now graphing this. It's literally going to continue this pattern. And it looks like stairs, right? And this is a function because it does pass the vertical line test. Because any vertical line, you have a closed dot and an open dot, they don't overlap. Does that make sense? Does the first graph use rays and not lines? Why does the first graph, use rays and not lines? All right, so each rule has a separate domain. If the graph contained lines, the domains would overlap. Since each rule is an inequality, with one endpoint, the graph contains rays. The greatest integer function is an example of a step function, a piecewise function that is constant for each rule. Use the graph of the greatest integer function to explain why a function is called a step function. Because it looks like a staircase, right, guys? Because the sections of the graph are horizontal segments that look like a set of stairs. Does the greatest integer function have a maximum or minimum value? Explain. Do we have a maximum or a minimum value? So, the answer is actually no. There is no point on the graph that is higher or lower than all other points. Alright, so writing and graphing a piecewise function. On his way to school from his dorm room, a college student walks at a speed of 0.05 miles per minute for 3 minutes, stops to talk to a friend for 1 minute, and then to avoid being late for class, runs at a speed of 0.1 miles per minute for 2 minutes. Write a piecewise function for the student's distance from his dorm room during this time. Then graph it. Alright, so at first he travels 0.05 miles per minute for 3 minutes. Right? So how am I going to write that? So that's going to be 0.05 times t. Right? He does that for 3 minutes. Then he stops. So he is 0.15. He is not moving from 3 to 4 minutes for 1 whole minute. Then from 4 to how many minutes? 6 minutes, because 2 more minutes. So from 4 to 6, he's going 0.15 plus the 0.10 times t minus 4. Because minus the first 4 minutes he's already traveled. Right? So it's complete the table. So at 0, where does 0 fit? 0 fits here. So it's going to be 0.05. At 1, 1 fits in here. 1 times 0.05 is 0.05. Did I just do 0 times 0.05 being 0.05? What is 0 times 0.05? 0. And nobody even said, hey, Miss Rubright, what are you doing? 2 times 0.05 is going to be 0.10. 3 also fits up here, so 3 times 0.05 is going to be 0.15. That's how far he's gone when he takes that break to talk to his friend. So then at 4 minutes is still under here, so he's gone 0.15. He hasn't moved. At 5 minutes, he started moving again, right? So 5 minus 4 is 1. 1 times 0.1 is 0.1. 0.1 plus 0.15 is 0.25. 6 falls under here. 6 minus 4 is 2. 2 times 0.1 is 0.2. 0.2 plus 0.15 is 0.35. Okay? So now we have to graph this stuff. So we're graphing 0, 0. We're graphing 0.05, 1.05. So 1.05. We're graphing 2.1, 3.15. All right. Then we stop and do nothing, right? So at minute 4, the total distance is 0.15. At 5, it's 0.25. And at 6, it's 0.35. So we paused, and then we continued. faster than we originally were. It's more steep, right? He's running faster than he was before because he needs to get there on time. He does not want to be late. Okay. Why is the second rule for the function d of t equals 0.15 instead of d of t equals 0? Because it's the total distance that he traveled, right? And he already traveled that 0.15, so we're not going to be like, oh, he traveled nothing. Just because he paused doesn't mean that he hasn't already gone a distance, right? So, d of t represents the distance traveled. And he has traveled 0.15 miles when t equals 3, right? He already traveled before he took his break. Why is the third rule for the function d of t equals 0.15 plus 0.10 times t minus 4? The distance already traveled during the first 4 minutes is 0.15, right? During the next 2 minutes, he goes at a rate of 0.10. Beyond the initial 4 minutes, right? So it's how much he already traveled times 0.10 for each additional minute beyond the 4 minutes he already did. Make sense? Write the equation for each function whose graph is shown. All right, so what do you have here? We have this one and this one. Make a table of values for the rays on the left. All right, so -1. At -1, you're at 1. At -2, you're at 0. At -3, you're at -1. At -4, you're at -2. At -5, you're at -3. Right? The value of y is blank more than the value of x. Plus 2, plus 2, plus 2, plus 2. It's 2 more, right? The equation of the line that contains the horizontal ray is y equals what? 5, 4, 3? Y equals 3. The equation for the function is, so when your when your x values are greater than -1, x value is greater than -1, it's that y equals 3, right? Oh, and this is already the y equals, so you're just going to write 3. Your y equals 3 when x is greater than -1, right? So when x is less than or equal to -1, so over here, then y equals, what is this equation of this line? Well, let's see. This slope is going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. The y-intercept would be at 0, 2. Your y-intercept would be at 2. So it's plus 2. Your slope is 1. 1x plus 2 is the equation of that line if that line continued forever, right? Does that make sense? Do you guys get what I'm saying? All right, so let's look at the next one. So between -2 and -1, so from -2 to -1, it's -4, right? Between -1 and 0, it's at -2. Between 0 and 1, it's at 0. Between 1 and 2, it's at 2. And between 2 and 3, it's at 4. Although the graph shows the function's domain to be -2 is less than or equal to x, which is less than 3, assume that the domain consists of all real numbers and that the graph continues its stair-step pattern for x is less than -2 and x is greater than or equal to 3. Notice that each function's value is 2 times the corresponding value of the greatest integer function. The equation for the function is y equals 2 times the greatest, what's that thing called again? The greatest integer function. 2 times the greatest integer function. Reflect. When writing a piecewise function from a graph, how do you determine the domain of each rule? For each piece of the function, determine the interval on the x-axis that corresponds to that piece. An open circle on the graph indicates the x value is not in the domain for that piece. How can you use the y-intercepts to check that the answer in part A is reasonable? So extend the first ray to see that it passes through 0, 2, which agrees with the equation y equals x plus 2. The second ray passes through 0, 3, which agrees with the equation y equals 0x plus 3, or y equals 3. All right, so let's do a couple practice problems. Let's do number 1 and number 4. Okay? So number 1. We're going to make our little XY table, right? So let's just kind of go like this. -2, -1, 0, 1, 2. So -2. -2 is going to fall under here. -2, -2 would be 2. 2 plus 1 is 3. -1 is going to be 1. And 1 plus 1 is 2. 0 plus 1 is 1. -1 plus 1 is 0. -2 plus 1 is -1. So we have, when x is less than 0, oh, I could only use that rule for these first two, right? I could only use that rule for these first two. Because here, when x is 0, it's just the same letter. So 0, 0. If x is 1, 1 is greater than or equal to 0, right? So 1 is 1. And 2 is going to be 2. You guys see how I had to double check and I saw that I messed up? So we have -2, 1, 2, 3. -1, 1, 2, right? How about if I put in a 0? If I put in a 0, I'd have 1, 0, 1. And that'd be an open dot, right? Because it does not include that. So this part's going to be going like this. Now, the one that includes 0 is at 0, 0, 1, 1, 2, 2, and so on. So that is your first graph. Take a minute to try the second graph. It's going to be all right, so -2, -1. If I plug in a 1 here, I would get -1, so we're going to do an open dot. So open dot going this way, right, guys? Closed dot here. 2, 2. 3, 4. 4, 6. That was just a mistake right there. But this is open dot going this way, closed dot going up. Make sense? Let's look at number 4 and see how to create this. So we have our f of x equals, okay? So for here, this is x values that are less than 0, right? So if x is less than 0. And then we're going to have something else if x is greater than or equal to 0, right? This one's greater than or equal to 0. So if x is greater than or equal to 0, our y is going to equal what? 2. Our y equals 2 when x is greater than or equal to 0. When x is less than or equal to 0, our y value is going to be this. Okay, it has a y-intercept of 1, and its slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So x plus 1. Y equals x plus 1 is the equation of this line if this line went on forever. You guys see how I did that? Does that make sense what I just did? Want to try another one like this one? Okay, so this one's going to be f of x. There's going to be 3 things. If. Okay. So this one, if your x values are less than 0, if your x values are greater than 0, less than 2. So between if x, I'm trying to think of how to write this. Yeah, 0 is less than or equal to x, which is less than or equal to 2. Is it not? It's not or equal to. Is less than 2, right? Between 0 and 2, including 0, not including 2. And then from 2 to ever. So like x is greater than or equal to 2, right? Kind of took me a second to think. All right, so if x is greater than or equal to 2, you have y equals 2. Over here, y equals 1. And then over here, y equals, it's going to be something x minus 1. Your y-intercept's negative 1. Let's see what our slope is. Up 1 over 1, up 1 over 1. It's a slope of negative 1. So negative x minus 1. Make sense? You guys following this? You getting it? The next one's obnoxious because it's a step thing, right? But it's not too obnoxious because don't we have our cheat sheet? Isn't this the steps? Right there? That's the steps. So this is just f of x equals x. All right, so normally, what do our steps normally look like? Whenever we did them before, they started at 0, 0, right? There was a step at 0, 0 when we first did it. Looking for it right here. Didn't we have 0, 0 and went from 0, 0 over to 1, right? Your stairs went here through 0, 0. Closed dot on 0, 0. Well, look, my closed dot that should have been on 0, 0 has been shifted 1, 2 to the right. So it's going to be, is it going to be plus 2 or minus 2? It's minus 2 because whenever we shift left and right, it's opposite of what you think, right? So minus 2. When you shift left and right, it's opposite what you think. So we're shifting minus 2. Make sense? You're taking your stairs, and instead of your stairs being at 0 and 1 right here, it's been shifted over 1, 2. 2 in the positive direction, and left and right's always opposite of what you think, so it's minus 2. All right, guys, so I'm going to actually change this up a little bit. So your homework tonight is 3-4 is going to be 145 and 146, so that part is normal. But we are not going to do 3-5 today because we just don't have enough time to get into it adequately. So I'm scratch your 3-5 assignment and the homework on that. So I'm going to go do that on your board. But I'm going to end this lesson right here. So like and subscribe. I hope you guys enjoyed what was this? This was 3.4, graphing functions.